तो कोई नहीं आया
क्लास में मिले आपको अब उन्हीं और रोहन को बोलना है ठीक है क्या हो गया Right, so let's begin the class session. I guess I left in between in last class, right? We were doing gravitation. So Come on, quickly close. Yeah, so quickly for the study, can you tell me something about gravitational force? What is gravitational force? Gravitational force. Can you say something about that? If you want to give you the chance to answer, can you the one the last step? What is gravitational force? Okay, and we need something what's of course which was acting between two objects, and what I'm saying, why something more which is you are the chance. You want? Okay, force acting between two objects. We have to say what kind of force is it? Is it force of attraction or force of repulsion? Attraction is very important. Okay, so gravitational force is a force of attraction between two bodies having some particular mass, right? And we did find that it is dependent on two factors, right? So can you tell me that force of gravitation, it is directly proportional to what? You remember that?
G mass into mass.
G mass into mass divided by
Distance.
distance square. So it is inversely proportional to distance square and directly proportional to the mass. What is this G? When do we put this G? What is it? What?
Constant.
It is constant of proportionality. So I have to remove this and change it to. Okay, so if you are putting G, then we have got it by removing the proportionality sign. So we did up to this part. So we know that any object throughout this universe, okay, each object which has mass will attract the other object, okay, with a force which is known as gravitational force, and that force is dependent upon the mass of the two bodies. Okay, yes, come. And how far are they from each other? So it is dependent upon the distance between them. All right, and then we had done up till this point, and I think we did SI units for gravitational constant as well. We did find that, and then I think I was asking you about the second law of Newton, right? So Newton's second law we did in last class. What is Newton's second law?
Rate of change of motion.
Is very close. Rate of change of motion. Momentum. Okay. Rate of change of momentum. Okay. And rate of change of momentum with respect to time, that means it is change of momentum. We say so it is final velocity minus initial velocity. You remember, right? V represents final velocity and U represents initial velocity. So mass into final velocity will be final momentum. Mass into initial velocity will be initial momentum, and we might to check how much is the change, so I subtract, and with respect to time, I plus it. So you remember, if we take mass common, then we are left with V minus 0.3, that is nothing but force into acceleration. Force is equal to mass into acceleration. So this formula is valid for this kind of force, be it gravitational force, be it magnetic force, be it any other force, right? So we will use this relation and apply it in the gravitational force formula. Are you getting the point that we are doing? So we know already gravitational force ka formula looks like this. Okay? But I have another formula for all the forces, which is forces given by mass into acceleration of the body. Okay? So if I take these two bodies as one body is our Earth, one body is huge planet, let's call it Earth. Okay? And the other body is any object like this pen in the vicinity of this. Okay, so this is represented by M, and mass of Earth is represented by capital N. Okay, and we know because of this there will be a force of attraction between them, right? And we call that force of gravitational force. And because of this force of attraction, this body will fall towards the Earth, right? And since it is falling, we know that fall is with uniform acceleration, right? It will, as it falls, a body जो नीचे गिरेगा उसका velocity क्या होता जाएगा? Increase होता जाएगा. When velocity is increasing, it is accelerating, okay? And that acceleration That acceleration is represented by letter G. You remember that? So this acceleration is acceleration due to gravity. Acceleration due to gravity of Earth. Okay. So I know already gravitational force formula, and I know that force can also be represented by this formula, which is mass into acceleration. Okay, which I found in the previous class for Newton's second law of motion. So what I will do is I will replace this force with the formula mass into acceleration is equal to gmm by d square. Okay, and here since this acceleration, I am specifically talking about Earth's acceleration. Okay, so this A will become acceleration due to gravity, and the formula will look like gmm by this d square. This d square, what is this d square? Distance between object and Earth surface, or distance between object and center of the Earth? Surface. Okay. And everybody thinks it's the surface. And you remember when I drew this diagram, I had specifically drawn the line like this from the center to the center of this part. Okay. So it is from the center of this body to the center of the Earth. All right. Please remember that. So the Earth center can be drawn. I just remove all these things. It can go, let's call this is the center of the Earth. So this whole right. So this is the center of the Earth. Let me just draw it properly. This is the center of the Earth. Let's represent it by capital R. Okay, and the remaining distance from the surface of the Earth we can represent it by the small r. Okay. Okay, or we can call this as d, no problem. Let's call this as the distance from the surface of the Earth. Then this d should not appear like this. I can't say d, I have to use some other letter. Let's call this d, no problem. So we'll make the changes over here. It's confusing. Let's call this r. So this becomes gmm. This is, we are taking acceleration. We are taking gmm by d square. Now this whole thing we are talking with respect to Earth. When we talk with respect to Earth and body falling on Earth, so acceleration will become acceleration due to gravity of the Earth, which is represented by letter G. G is the gravitational constant. Mass m is capital M is mass of the Earth. Okay, and small m is mass of the body, which is falling, and this distance can be rewritten as r plus r with the whole square. Okay, are you getting the point? Now this g gets sorry. This small m and this small m gets cancelled. All I am left with is g is equal to gm by r plus r with the whole square. Are you getting the point? So we have new relation now. We in last class already saw that gravitational force of attraction can be given by gmm by d square, and d is the distance between the two objects. That same relation gives us value of acceleration due to gravity. Okay, we get acceleration due to gravity's formula, which is with respect to gravitational constant into mass of the Earth upon r plus r square, where r is the radius of the Earth, and this small r represents the distance of the body from the surface of the Earth. Is this clear? Now this g is in this case, this g is gravitational acceleration of the body on Earth, right? If I take this body and go to moon, okay? So moon पर फिर से drop किया, तो since फिर से ड्रॉप होना है मून पे? No, right? Why? Because compared to Earth, mass of moon is what? Lesser or more? Less, right? So then acceleration due to gravity will be somewhat different, right? This g value will be somewhat different, right? So this relation give us value. This relation can give us value for anywhere on the planet. Okay. If I take this g as gravitational acceleration due to gravity of Earth, then that can be given as, let's call that letter P for Earth. Gravity, this is acceleration due to gravity on Earth, is equal to g mass of Earth upon r, which is radius of Earth, plus r. This r is actually not, it's kind of misleading, but then we have got it from here. You might get confused. So always remember that r is distance between the surface. Okay. And if I take this to moon, I can use the same relation and I can write it. Acceleration due to gravity on moon can be given by, of course, this is constant, that will remain same, it will not change. This mass will become mass of moon upon this radius will become radius of moon plus r. Is this here? So we have another new relation. Please write, this is very important for acceleration due to gravity on any planet or on any surface. If you are able to, a body is moving towards any star or any planet with anything, it is valid. Provided it is moving with some uniform acceleration, it is relation. What better they are doing. So in physics, we always, it's a very important point that I'm coming to. Physics, we always use approximation. Approximation in the sense, अगर कोई आपको पूछे इसका measurement कितना है, ठीक है, इसका length कितना है. It is up to you. If you are taking a ruler, you can go up to what 0.1 centimeter value, right? But if you want to just say approximately, if the length of this table is, let's say, 200.2 centimeter, how much? 200.2 centimeter. Can I say, it is actually 200 centimeter? Approximately, can I say? Yes, why? Because point is very small compared to 200. Similarly, in physics, you will see most of the time, this is the actual relation where this distance is r plus r with the whole square, where r is distance between this r is this, okay, from the center of the object to the surface, and then this is this. But the thing is, if you look in the actual scenario, this chota r is very small compared to the radius of the Earth. Agreed or not? हाँ, Earth का radius तो कितना होगा? 6,070. And this radius from which the object is falling, not the radius. The distance from which the object is falling is very small. So you will see in your textbook they have neglected this thing, this chota thing, because it is very small. It can be neglected, not negated. It can be neglected, and we can say that it is nearly equal. You know the sign, right? It is approximately gm by r square, where r is the radius of the Earth. Are you getting the point I'm trying to make? Huh? Is this clear? Okay, so the point I'm trying to make is look at this thing. This is not the approximate diagram. ठीक है? इतना radius of the earth है. Object इतना दूर से नहीं आ रहा है. ठीक है? Object ज़्यादा से ज़्यादा कितना 1-2 किलोमीटर 100 किलोमीटर वगैरह. या तो हम तो meters के term में बात करें. The body that is falling. So in reality, if I try to depict the picture, in reality, if I try to depict the picture, the object is falling from this distance. Are you getting the point? This R is very small compared to this R. Are you getting what I'm trying to say? That is why in physics, most of the time you will come across approximation part. So they say that this plus this is a very shorter factor, like 200.2 bolo or 200 bolo, because nearly same. So that is why they neglect this shorter R, and they say that this G can be given by Gm by R square, where R is the are you getting the point that I'm giving? So that this is how, if you look at the textbook, do not get confused why they are avoiding the surface of the R distance. Why? Because it is approximation that we do all the time. So this is again GME by R square. Here we will put GM by. Is this here? Finish this video. Understand? Yes. So let's start with one small activity that they have. We will discuss that because in that I need to check how much you understand. So let us activity, most of the time they are good, quite and then we'll start with let's start with numerical. We'll have to start with it. Is this done? Can I erase this? Yes. I thought E was done and the values. Where are we? What was this? This was our last class relation. Here by B square. And we have replaced this. This is kept as it is. And then we substitute this with respect to R. So this becomes G acceleration to gravity. And this is G M M. This is R plus R. R plus R with the roots. Go then what? What capital D?
G.
What does capital G represents here? Oh, this gravitational constant that we introduced in last class. You remember constant due to proportionality constant. In last class, we saw that F is directly proportional to product of the masses. F is inversely proportional to the square of the distance. You bring them together, it looks like mm by d square. To remove this proportionality sign and make it equal to, we have to introduce a constant, and that constant in this case is G. Okay, so G is constant, gravitational constant. Yes. And this mm gets cancelled. Yeah. And please remind me when this class is about to get over last time. So, before start with the numerical, I would like to do all the three numeric equations of motion. I did ask you to learn them by heart because in most of your physics classes, we will be using those kinematic equations of motion. So who should we start with? Can we start with you? Can you give me the first kinematic equation of motion? Huh? Please give the first one. So V is equal to U plus AT is the first one. Yes. The second one. S is equal to UT plus AT square. UT plus AT square. Are these two correct?
No.
Which one is wrong?
S.
Where is wrong? So here it is half AT square. Okay. Yes. Third one.
S square equal to U square plus 2S.
S square is equal to
U square.
U
UT square. UT square.
what?
UT square
UT square. Okay.
plus 2AS.
Okay. There are two A. There are two S here also. There is S here also. V.
And B square.
So is it V square is equal to UT plus 2AS? Then
B square equals U square, U square plus.
this is the last one. V square is equal to U square plus 2AS. Please remember this. Yes. Yes, of course. And you can also write V square minus U square is equal to 2S. As far you go correctly, it's fine. Yes. And what does S represents in this? Can you tell me what does S represents in this? Okay. Can you tell us? Distance, okay, or displacement, because we are talking about straight motion, straight path. So these are valid for straight path motion, and that motion should be uniform accelerated motion. All right. So yes, these three are the ones we will be using them. Before we jump into that, there is one small activity that we will do, and there is one short story which I know you also know it. But then there's no harm in discussing them, right? So we all know Newton and the apple falling on its head, then gravity, force of gravity is discovered, right? So yes. So this apple falls down on this earth. I made it very small because I need to bring in universe into this. So let's not make it huge. So this was earth and this is falling down. This apple is falling down. And then, he realizes, okay, maybe, this earth is attracting it. That is why this apple is falling down towards the earth. It's falling towards the earth. Then he questions himself, which you will answer, all right? He questions himself, this is fine. This I understood that, it falls down because earth is attracting it. But then there are other things like moon. Okay. Moon is revolving around this earth. Right? And why is it revolving around the earth? He gives the reason what? Gravity. Again, it is due to gravity, right? Gravitational force of attraction. Then, how is it rotating? How is it not rotating, revolving around the earth? And any object in the universe, it is revolving around the earth. It has something to do with gravitational force of attraction. This confuses a lot of students. So the thing is, of course, it is gravitational force of attraction. Did we do circular motion in last class? In the previous chapter, circular motion. So for any circular motion, right? If there is a stone, if you tie a string to it and then you try to revolve, then it is revolving. That stone is revolving in circular motion. Why? Because the other end of the thread is in your hand, right? The moment you leave the thread, will it continue revolving? No, right? Basically, you are providing that center major directed force. So with the help of the string, right? You are providing that force due to which that stone is attached. It is revolving around that point. So here also this moon is revolving around this point, which is known as Earth, due to some force, and that force is gravitational force. That is Earth's gravitational force. Now the question that most of the students, of many of them think, then why it is not falling down towards the Earth, like the apple? Why is it not falling down towards the Earth? Now, can somebody think about this? There's something extra, but then if you can do why, then you know, we can discuss more about this. This is just for your curiosity. I'm just trying to instill some curiosity in your head. You can think over it, take this question and go, and then think more and then come with the answer maybe. Okay, or maybe towards the end, if you have any answer for this, you can take it. The question is clear to you. So, we are providing this. The question is like, if the apple was there, if it is released, it will fall down, right? Fall down towards the earth. This moon continues to revolve around the earth. Why? So she has one answer. She is saying that the earth is providing the continuous force which it is circulating. All right. Think about this. Let me know the answer. Oh, she has. Not. Are you writing the question? Okay. Write it down. We are moving to next. I'll give you time to think because I don't want to rush and just give you the answer directly. So see, it is very interesting. And it has something to do with the previous Newton's law of motion. Try to think about that and then try to correlate. Maybe you will find your answer. So now we are moving to that activity. The activity is you have to take a sheet of paper and a stone, drop them simultaneously from the first floor. This is the activity which is done by the second. But then what will you observe? Observe whether both of them will reach the ground simultaneously or not. And yes, so I will throw a stone from here and a piece of crumpled paper from here. Which one do you think will fall down? First stone, and the other one will slowly fall. Okay. Why will paper take time? Okay. Interesting question. Now let's say I take paper of the same mass as that of the stone. छोटा सा पत्थर लिया है, करीबन कुछ ग्राम का पत्थर लिया है और बड़ा सा मैंने उसी के मास का क्रम्बल करके पेपर लिया है and then I will throw them. ठीक है? और अभी ऑब्जर्व करेंगे आप तो what will you see? Which will fall faster or which will hit the ground first and what is it? It's very scary now. So which one will, since you said mass was the crucial factor, so I'll make them of same mass and then let it fall. Which one do you think will fall first? This one will fall first. Okay. Of course, that will be the case, but ideally, what is the reason why paper is getting, paper will take time to hit the ground and stone will go faster? What is the reason? Not mass is the actual reason. It is the air resistance. You also know that अगर paper को ऐसे ही फेंक दिया तो शायद उड़ तक कितना time लेकर नीचे चला जाता है. It is not the mass component which you talked about. It is the air resistance which is the reason. Okay. Okay. So ideally, if I take a lab structure, I do this experiment in a lab such that I remove the whole air out of it. Okay. Air is removed. I create a vacuum. Vacuum for that, right? There's nothing inside. A vacuum, and now I drop stone. This one, let's call this a stone. This one is paper. Both of them are of same masses. Okay, and I drop them from the same point. Okay, which one do you think will fall faster, or which one do you think will hit first? In this case, there the whole air is sucked out. Both will hit the ground at the same time. All right. So this is this scenario where this body is falling solely under the effect of gravity. यहाँ से air resistance सब निकाल दें. The only reason why this falls down is due to gravity. The only force which is acting on these two bodies is what? Earth's gravity. So this scenario is known as free fall. So many a times you will come across such words that a body is undergoing free fall. Whenever they say free fall, henceforth when you go to any grade, whenever they say free fall, that means the force that is acting on this body is only the force of gravity. Okay, there is no upward air resistance or no other force, no drag, nothing. It is only solely gravity. Okay, under the effect of gravity, it is falling down. Okay, and this one, if you take this formula, you see this is S is equal to UT plus half AC square. I'm giving you hint and I'm changing the question. This is the hint. Now the question is, this is the stone and I take another huge stone. Of course, this has more mass than this. And then I drop them. Which one will hit first? Bigger one. The hit is the distance traveled. So both of them are released on the same height, right? In 1 second, if I put 1 second value time here, then how much will be the value? So S, distance covered by the first one, let's call this the first one. This is the second stone. So distance traveled by the first stone would be, this is 0 because initial velocity is what? 0 plus half. Acceleration due to gravity is what? G 9.8. Let's take it 10 for easier calculation. So that is 10 into t square. How much after 1 second? So how much is the distance traveled? 5. S2 will be what? S2 ke liye UT again is 0. This is half. This is again 10. Again 1 square. This is also half. 5. Are you getting what I'm trying to say? It is not dependent on mass. So these two will also hit the ground at the same time, right? Because both of them are experiencing what? Same acceleration due to gravity, right? ऐसा करिए कि इसके लिए acceleration due to gravity की value जो है 10 है, इसके लिए g की value 20 है, ऐसा कुछ भी नहीं है. So both of them are experiencing same acceleration due to gravity, and if these two are under free fall, okay, at the same instant they will hit the ground at the same time. So just activity clear in your head. But if they talk in terms of the normal scenario where the atmosphere is present, then we definitely know. They will of course not give you such complicated idea because structures will not matter. But then paper and earth, paper and stone, you know which will fall later. The paper. The reason being air resistant. But the paper and stone taken together in a vacuum, if this is and this is paper, irrespective of what mass they have, they both will hit the ground at same time. Okay, this is the activity. Now take one question and try to solve that. The three formulas are over there. The question is, a car falls. We have solved the question, but what can we let's do it for this? A car falls off a ledge and drops to the ground in 0.5 seconds. A car falls off a ledge and drops to the ground in 0.5 seconds. Let g, small g, acceleration due to gravity, be equal to 10 meter per second square. They are asking you to take g as 10. Calculate first thing, what is the speed on striking the ground? So this car will strike the ground. So what is its speed when it strikes the ground? A car falls off a ledge and drops to the ground in 0.5 seconds. A car falls off a ledge and reaches the ground in 0.5 seconds. Take G as 10 meter per second square. The first question they are asking, what is its speed on striking the ground? Is this done? The second one is, what is its average speed during 0.5 seconds? How high? Okay, second one is done. How high is the ledge from the ground? How high is the ledge from the ground? The scenario is here. There is the first thing that they are asking is, what is the speed, final speed when it hits the ground? So they are asking for final speed. Okay. What is the given information? T is given, T taken is 0.5 seconds. And initial velocity, of course, we know is 0 meter per second. And G is 10 meter per second square. So for, of course, V, what will be used? Which formula will be used? Which equation? The first one, because we have all the components. Quickly give me the V value. Five is correct. Go for the next one. The first one is pretty straightforward. Go for the second one. What is the average velocity? That's the most interesting one. And the last one is the distance traveled. Whichever way you have. Give me the value quickly. What's the answer? It's not very good because division problem. So I believe in next class will be starting with the topic. All right, we have much time. The answer is 2.5, and it is straightforward. This one you cannot go wrong if you substitute the value properly. G is of course positive, and the second one. For the third one, of course, S is to be used, displacement, and average will come out as 2.5. Did you do the correction? All right. And in next class, we will be doing important difference. We will be starting with two topics and we'll be closing this. Let me quickly now the formula for gravitational force. The universal law of gravitation. Quickly tell me the expression which will find that. Why we have used GMM upon S. GMM upon D square, that is equal to the gravitational force. Can you tell me the acceleration due to gravity is given by what? The small letter g, the expression for that is what? The today the relation that we derive. That is
GM upon R plus R.
Gm upon r plus r is the whole square, and we approximate it to Gm by r square. What does r represent in that? R represents in terms of Gm by r square. Radius of the earth. What does G represent in the whole thing? Capital G. And small g represents its acceleration. All right. Can you tell me the first equation of kinematics? The second one, can you tell me? The third one is E square is equal to square plus 4. All right. So in next class we'll be starting with mass and the weight, and I'm not going further in these questions because we have already done these questions in last chapter. We have used quite a lot, but we had one question that I could give you since we are going to another chapter this part. So I just gave one question, but I would like to give homework. Did I not give any homework in last class? No. Volume. I just did some. Close the answer. Very close to the answer. It's very close to the first law. Not think about this in the other lectures, okay? Otherwise, you will have only physics and hypothesis. Please take homework. Question 5, page 37. Question 5. Page 37, question 5. Page 37, question 5. Can you show me what is the page? Oh, there's the page number right. Yes, go to page 41, question 5. Then go for eighth question, eighth one. And 14th question, please try 14th one. 14th and 15th both. Sorry, 13, 14. 13, 14, 15, all three. When are we meeting next? Thursday. This Thursday? Yes. Only Thursday. And so 15, that's fine. Otherwise, 13, 14. Yeah. See you next class. My phone. Just check my
Yeah.
Yeah. Yeah. For example, I didn't have one wrong.
Then what do you do? Huh? Hola there. Good evening to you all. Good evening to you all. Still, I did not hear from anyone. Good evening to you all. Fine. How are you? Why you came late?